Howdy everyone, and welcome back to another episode of Understanding Neovim. It's episode number 9, and in this episode we are going to be discussing completion engines, which are a particularly important topic both for programmers and writers alike. In this video we're going to discuss what a completion engine is, why we might even want one, and also what completion engine we're going to be choosing. And of course, in the typical Understanding Neovim style, we're going to peek behind the curtain a little bit, and we're going to take a look at what makes various completion engines tick, and we're also going to look at various componentry that is critical to the functioning of a completion engine. So let's begin with the most obvious question. What even is a completion engine? Most people think they know the answer, however, the answer is usually too specific. A completion engine is simply a pop-up that displays on your screen as you're typing something in the buffer. Now, the goal of this pop-up is to show you various entries that are attempting to predict the thing you're currently typing. Not like AI or anything, but just by using pure algorithms. So in the context of programming, if I'm typing out a variable name, the goal of the completion engine is to display all variables in the current file that begin with the characters that I typed. In the context of writing, you could use a completion engine to display various spelling suggestions for more complicated words as you type them. What I'm trying to underline here is that completion engines can do a whole lot of stuff. Anything that's got something to do with text prediction is basically doable from the standpoint of a completion engine. With that, I think it's an invaluable tool to have no matter who you are and what sort of things you use Neovim for. You'll probably find a use case for a completion engine, and that's why we're covering it this early on in the series. Now that we have that out the way, we need to answer a very important question. Which completion engine are we choosing? Because as it turns out, there are of course many completion engines. It's Neovim after all, and you have no vendor lock-in. You can choose whatever you want. There are many plugins that do this. However, for simplicity's sake, we're going to keep it straightforward for this series, and we are going to be using blink.cmp. It's a fantastic modern tool that's learned from the mistakes of its predecessors. It's very easy to set up, has very little configuration burden, and it's also a nice way for me to introduce you into completion engines without overloading you with information. It's also very capable, by the way, so if you think we're using something too simplistic, we're not. This is actually a fully featured package that we're going to be installing. Before we get to the installation, there are two very important notes. First of all, if you're currently on a version of Neovim below 0.11, I really encourage you right now to go and update your Neovim to a more modern version. Specifically, as of the making of this video, the latest stable release is 0.11, and that's the thing you want to have. If there's something newer, if you're watching this video 50 years into the future, then obviously use that more modern version. However, 0.11 marks the start of some nice LSP utilities which are going to make our configuration much simpler, and it's going to require us to write less lines of code. It's been out for long enough by now, so it should be available on all your favorite package repositories. If you're on Windows, just go and fetch the latest version and you'll be set. Also, since 0.11, Neovim has actually had its own built-in completion engine of sorts. However, we are not going to be touching upon that completion engine in this series, mostly in an attempt not to overcomplicate things. However, if you do want me to do so, I can create a separate video on the built-in completion system. It's not really fully built out yet, however, it is flexible enough and it is already pretty capable as it is. I still believe that we should use an existing package like blink.cmp just for ease of use and for the out-of-the-box experience. Okay, with that, let's move on to the installation. So here I am on the blink.cmp official GitHub page. You can see it's a performant batteries included completion plugin for Neovim. As of the making of this video, it is on version 0.1.1, nice, and has a very healthy and active community, as you can see. If we scroll down a little bit, you will see that there is an installation header, and it tells us to head over to the documentation website. So I've already done that for you, and here it is. Over on the left, we have the installation section, and that's obviously what we're interested in. If you see this warning, we're going to be talking about this in a second, so keep that in the back of your mind. First of all, the requirements. Make sure in Neovim 0.10 plus, of course I recommend the Neovim 0.11, and make sure you have both of these binaries available on your system. For Windows users, you only really care about having Git on your system. If you're a developer, you're already going to have it. For most Linux users, curl is already available. Mac users, curl is also already available, unless you're on a really esoteric distribution. So very minimal requirements should work for everyone. As for Rust Nightly or Rust Up, you don't actually have to have this because we won't be building from source, as I'll show you in a second. Here we have the lazy.envim section, and as is custom, we are going to copy over this entire sequence. However, then we are going to go through each flag, we're going to explain it bit by bit, and as we do so, we're going to trim the comments since we're no longer going to need them as we're going to fully understand our configuration. So let's go. So here we go. I've pasted the configuration, and goodness, what is it with people and single quotation marks? Jeez, if you just allow me, I'm going to quickly modify this. Every single quotation mark, there we go. You don't have to do this, by the way. I'm just going to change all of the quotation marks because it drives me crazy. Okay, so blink.cmp is now going to be installed. So let's go through everything bit by bit and explain it. First of all, we've got some dependencies set up called friendly snippets. We're going to get to snippets near the end of this video. However, I recommend you keep this because it doesn't cost you anything. It doesn't cost you startup time. And as you will see later, it's actually a very handy little thing to have. Next up, we have version. And interestingly enough, we haven't had any experiences with versioning in any of the previous episodes. So this is this is the first time we're actually being exposed to versioning in a plugin. What does this all mean? Well, if you've been an astute viewer, you might have seen in the GitHub repository that there was a releases tab, and I showed you that. I said, okay, the project is on version 1.1.1. Now, these releases are actually what Lazy uses as its source of truth in order to find various versions of a plugin. Now, if we click on this latest release, you'll see that it's actually bundled with a set of assets, and these assets are going to come in key in just a second. But for now, let's take a look at this syntax. This syntax is basically saying that we want to choose any version that begins with the number 1. If it begins with the number 1, we want to choose it. Basically, this ensures that we are kept on a stable version and that updates to the plugin will not break our plugin and will only get feature updates instead of breaking changes. Of course, if you're watching this far into the future where there's a version 2.0 or a version 60.0, then you can use that. As our configuration is so simple, I don't believe it'll drastically change even in years to come. Now, this comment is quite peculiar because it's telling us that it's using a release tag to download pre-built binaries. What does that really mean? Well, this brings us back to these assets, because blink.cmp is pretty special. Usually Lua plugins are written in, well, Lua, and blink.cmp is no exception to that. However, it has a small component in it which is not written in Lua, and that is the fuzzy matching algorithm. As it turns out, the fuzzy matching algorithm is a tiny Rust library that is embedded with the project, and what that allows it to do is it allows it to use that fuzzy matching algorithm, which is very powerful and very, very fast. And what you see here is that Rust library, however it's compiled for various operating systems. So when we install the plugin, what blink.cmp is going to do is it's going to cross-reference this version over here, and it's going to look in the GitHub releases over here. It's going to try and find the correct library version for your operating system, and it's going to download that and then use that as its fuzzy matching algorithm. But let's dig a little bit deeper. Why are we using a different language? What's the point of that? Can't we just use Lua? Well, there is actually a Lua fuzzy matcher inside. The reason this is done is because blink.cmp needs to sift through tons and tons of data. At times, it needs to sift through thousands upon thousands of entries basically in milliseconds. Think about it. Let's say you're in a very large code base and you start typing some text. Well, blink.cmp needs to immediately gather all of the relevant completions for the thing you're currently typing. And as you can imagine, it needs to sift through a ton of information. Lua is fast, but it's simply not fast enough to be able to sift through all of that at once. So that's why the developers decided to write a Rust library, because it goes fast. I feel this is really important to mention because if you ever have an error related to this, you'll at least know where to start looking for problems. So now that we understand that, we can remove all of the comments below because they are now irrelevant. Next up, we have some LuaCats annotations. We are not at a level to really understand these yet. They're not that complicated. However, I would like to discuss LuaCats in a completely separate episode. So for now, we're going to remove those and pretend those never existed. Next up, we have this opts field, which I never explained for some reason in the previous episode. This is a feature of Lazy, of course, and it's simply a shorthand for running a config function with require blink.cmp.setup and these arguments. If we go up a bit to mason.envim, if I were to type opts equals this single line is equivalent to this entire section. So basically opts is a shorthand for running the require call .setup and then the arguments. If I provided some value like a equals 3, then that is equivalent to supplying a equals 3 into the setup function. And here we have a list of key maps and various options related to blink.cmp. But before we get into these, let's actually see if blink.cmp works in the first place, and then we can work on tweaking it to our liking. So I'm going to save and quit, and I'm going to re-enter our plugins.lua file, and you'll see Lazy doing its magic as it usually does. And you may notice there is a nice little message at the bottom here with blink.cmp telling us it's downloading the pre-built binary. Now, it hasn't errored yet, so I can only assume that it has succeeded. It doesn't actually print a success message at this point in time. And so what it's done behind the scenes is it's gone to the GitHub releases, it's pulled the proper version of the library, and it's now hooked it up to blink.cmp, and it's ready to rock and roll. So I'm going to leave this, and the first thing I would like you to do in order to test this is to make sure that your Lua LSP is active. If you don't have it, install it through Mason, and then it should be enabled. You should notice it's enabled because you get a bunch of warnings related to Vim not existing. We are going to solve that in a future episode, don't worry. But for now, I'm going to go down, let's say just right here, and I want to see if it works. Well, we have this variable up here called lazy path, so let's try referencing that variable and see if blink.cmp is capable of auto-completing it. So I'm going to start typing L, and well, there you go. Right away, we have a pop-up window, and the first entry that it shows is lazy path, so it has successfully predicted what we're trying to type. So let's talk about navigation a little bit. If you want to move up and down, you can use Control-N and Control-P. That's going to move up and down. If you'd like to view documentation for a specific thing, you can press Control-Space, and that's going to show a nice window to the the right, which is going to show you various documentation. So if I go down to load, press Control space, it shows me what load is, how it works, and what it does. Now let's quit out of this word again and let's type L again. If I'd like to accept a completion, by default I have to press Control Y, which I like to think stands for Control Yes. So when I press Control Y, you can see it automatically auto-completes. So nice, blink.cmp works in its current state. That's fantastic. So now let's go and configure it a little bit more to our liking. The first thing we can change is the key map, and the default key map is not really something most people like. I actually love it and I use it in my own configuration, mostly because it's very in line with the default Vim key bindings. So if you're a purist, then you'll definitely want to keep it on the default preset. But in the comment here, you can see that there are many other options that you can select from. If you're coming from a regular IDE like VS Code or IntelliJ or whatever, then you'll probably be used to the super tab key bindings, and that's probably what's most comfortable for others. So I'm going to go down into this line and I'm going to change the string default to super-tab. You can even see that blink.cmp is auto-completing that from the buffer source, which we'll talk about in just a second. So I'm going to save and quit and re-enter, and let's try the same thing we did earlier. So I'm going to press L, and now instead of pressing Control Y, I'm going to press Tab, and that's going to automatically select the thing I've currently selected. Awesome, so we are going to now delete this, very nice, and let's move on to appearance. This section we can gloss over roughly because it is very technical and it's actually outside of the scope of Neovim. However, I would like to touch upon a few things here. All we're doing is we're setting the variant of nerd fonts to monospace. If you have a problem in your completion engine, if I would just press Control space, that these icons over here are not displaying or that they're broken, make sure you have an installation of nerd fonts, and that should fix the problem. If not, refresh, restart your system, and it should start functioning again. What we're doing in this specific line is we're instructing blink.cmp to use the monospace version of nerd fonts. Basically, all that does is it ensures that all the fonts are the same width, and that means all of the icons look consistent. If you're an expert and you have your fonts nicely tweaked, or you know that your fonts are set and work in a TUI well, you can set this to normal, and that does sometimes bring better results. However, I do recommend sticking to the default and using mono. Next up, we have some completion options. There are much more of these, however, these are the default ones provided in the default snippet, of course. If you'd like to see more, you can see the help page for blink.cmp. They have quite a few things. There you go, right here. Now, all we're doing here is we're setting auto show on documentation equal to false. I actually don't like this. I actually prefer this to be true. And what that's going to do is now, as I start typing, it is automatically going to show that documentation pop-up on the right instead of me having to press Control space again to enter it. So if I save and quit and re-enter and I go down to where I was, if I start typing lazy path, you can see it automatically shows the window on the right here, and I don't have to do that myself. So that concludes the first half of our options, and from here on we are now going to go more into the weeds and we're going to explain how these completion engines actually tick, because here we have a list of sources, and these sources are actually what make the backbone of blink.cmp. If you remember my definition from the very beginning, I gave a pretty generic one, and it was obviously not without reason. Is because blink.cmp can theoretically display anything in its completion window. However, most people just use it for the LSP pop-up, right? But of course, it can display much more than that, and this is where sources come into play. A source is simply a bridge between some data and blink.cmp itself. Now, what does this really mean? The way you can think of a source is as a mini Lua plugin. Blink.cmp ships with a bunch of these mini plugins embedded by default inside of itself, which just makes it easier for new time users to get up and running immediately. However, they don't have to be built into blink.cmp. You can actually write your own plugin which behaves as a source that blink.cmp can use, and that's where the real power comes into play. But for now, let's take a look at the default sources. You'll see we have the LSP source, the path source, the snippet source, and the buffer source. So what do these really do? Well, the LSP source is actually the thing that grabs data from the LSP server. So it contacts the LSP server and it says, hey, I'd like all of the completions at this point. The LSP server then returns a massive list of all of the possible completions at that position, and then the LSP source forwards that to blink.cmp, which sifts through all of that data and displays it to you nicely in the form of a pop-up window. The path source can auto-complete paths for you, and it's enabled by default so we can see how it works. If I type /, here you go, it automatically starts showing various things in my file system, which is really nice. If you're typing out paths, it can automatically suggest existing paths on your file system. So I can do /home/ and then you can see it shows my two directories, which are lost and found and Viro. We'll ignore the snippets one for now, and let's talk about buffer. Buffer is a really interesting source, and it's mostly useful for people who write a lot of stuff as opposed to write code. Buffer will take all of the current words in this file and will feed them into blink.cmp, so you can reuse the words that you've already typed. You might think that sounds completely ridiculous, however it is actually surprisingly useful. incremental. And you saw it being useful previously in the episode when I said that the buffer source was kicking in. As an example, I'm going to go into this string, and let's say I want to type out the word dependencies. The word dependencies already exists up here, right? So the buffer source is going to take a snapshot of that word and is going to feed it into blink.cmp so we can get it as a suggestion. So if I start typing out dependencies, you can see this text node here, which tells us it's coming from the current buffer, and here we go, dependencies. The word node decremental and node incremental also appear in this current file, which is why they're being recommended to us. Quite a handy tool, and if you do a lot of writing, you'll see that it will save you some time. So with that, we can delete this comment and we can move on to the last little section, which is just the fuzzy implementation. We're going to keep this as is because we want to use the Rust fuzzy matcher. If you absolutely hate Rust for some reason, or you just don't want to have a library installed onto your system which you don't have full control over, which is fine, you can set this to use Lua instead. As you can see from the comments, it says that you can use implementation equals Lua to use the Lua fuzzy matcher, which is slightly weaker and also slower. However, it's there in case you absolutely need it. But we're going to keep it as it is. We're going to keep it as prefer Rust with warning, meaning it's going to show a warning in case it can't download the proper Rust library. Okay, that's fantastic. We are done. However, we still have some unsolved questions. You'll notice I never really talked about these mysterious snippets. What are those? Well, bear with me because there's one more important factor that I'd like to talk about, and it's actually completely hidden from view here. In fact, even if I gave you 10 minutes, you probably wouldn't be able to find it because blink.cmp does it automatically for us. What I'd like to talk about right now are LSP capabilities. Since Neovim 0.11, we have this magical ability to automatically set a configuration for all LSP servers at once. This was not a possibility before Neovim 0.11, but I'd still like to talk about LSP capabilities because I think they're an important thing in understanding how a completion engine ticks. Let me showcase what we used to have to do. If I just go over to the documentation for blink.cmp again, and I scroll down, you'll see we already have a section on LSP capabilities, and you'll see the warning stating that on Neovim 0.11 plus, you can skip this step because Blink does it for you. So let's take a look at this snippet. You'll see that this snippet sets up LSP config, and it does this really weird thing. It basically, before setting up a server like we do in our configuration right here, right before you run lsp config server name.setup, we supply an empty table here. However, what they do here is that they set the capabilities variable to this long thing and then set that up with the actual configuration. So what's really going on here? Why was this a necessity and why do we not need to do it anymore? So think of it this way. You're an LSP developer and you've just created a fresh new LSP server that you'd want everyone else to try out, but it's not quite complete. Then your users try it out and say, oh, it's broken. I tried renaming this variable. However, your LSP server isn't capable of renaming stuff yet, and so everything crashed. Well, LSP capabilities serve as a way to safeguard against this. They are literally a list that the client and the server send to each other when they first connect. And it's a long list that basically says, here's what I support and here's what I don't support. Both the server and the client send it. So Neovim has its own list of capabilities, and then the server, whatever it is you're using, in this case Lua language server, sends its own list of capabilities. And this allows them to actually set a standard for what sort of exchanges they should be making. For instance, if Neovim knows that the server does not support renaming, instead of trying to send a rename request, it will simply say, this server does not support renaming because the server told me that it doesn't have that capability. That sounds a little bit like magic. However, of course, nothing is magical in Neovim. It all has grounding, and we can actually take a look at what this capabilities list looks like right from our editor. So I'm going to run this command here. I'm going to run lua vim.print, which means we're obviously printing a table, and I'm going to run vim.lsp.protocol, and then here I'm going to press Control Space because I want to show you something magical. Blink.cmp also works in the command line, they're just saying, so you can also use completions in the command window. I think that's super cool. But as we're typing here, I'm going to type make client capabilities, and there we go. That is what we want to run. We want to vim.print the output of vim.lsp.protocol.make client capabilities. And here we go. You get a very long table, and this table is exactly what Neovim sends to every single LSP server when it first connects to it. If you'd like, you can have a read through this. I don't really expect you to understand everything here. Not even I understand everything here because I'm not an LSP specification wizard. I like to know that there is grounding in things that I work on and that it's not just pure magic. So here you go. So why do we need to even configure those capabilities in the first place? Well, blink.cmp does more than what Neovim can do by default, because remember, Neovim has a very limited completion engine by default. So when Neovim connects to a server, it has the limited completion capabilities because it doesn't support them. But blink.cmp is a much more complex and vast completion engine that supports a lot more. So we need to alter these capabilities and tell the LSP server that we're connecting to, hey, the thing you're connecting to has advanced completion engine capabilities, which means you can send all sorts of more data than you otherwise wouldn't send. If the things I told you came in one ear and flew out the other ear, don't really worry, because if you're on Neovim 0.11, of course, this is all done under the hood. Blink.cmp just does this for you magically, which is awesome. However, I still think it's important to know that that thing exists, because I have seen some errors here and there related to capabilities, and some people might be confused what on earth that really means. However, now that you know, it should be quite easy to troubleshoot what is going on, and it should be quite easy to create an issue on the repository of any plugin that might be affected. Okay, now we can finally move on to the ending part of this video, snippets, the magical thing. I love snippets so much, and if you don't know snippets or you don't really use them as much, I hope I can convert you a little bit. But before we get into that, let's actually talk about what a snippet is. A snippet can be seen as a template for text. It's literally all it is. It's scaffolding for text. And to show you what that really means, let's go down to the very bottom of this file. I'm going to type out an if statement from Lua. So if, and here you can see it's automatically giving me a completion here. And notice that it looks a little weird. It has a tilde at the end. And that tilde is blink.cmp telling us that what we have here is a snippet. So let's accept this snippet by pressing tab, and something magical happens. The entire thing expands and we have a whole complete if statement. Right now, we can see that the true is selected, which means I can start typing. I don't have to enter insert mode or anything. I can just start typing. So I'll say if my condition, and then what I can do is I can press tab again, and now my cursor moves into the if state. If you're coming from an IDE, this might seem really normal, but it's actually pretty magical how this works under the scenes, and that's why I really want to share it with you. Now, snippets can be as simple as these if statements, and they can become very, very complicated and also incredibly automated. You can create entire to-do lists in snippets if you wanted to, with everything automatically reordering itself and updating in real time. It's pretty awesome. If you'd like to see some cool things you can do with snippets, I will leave a link to TJ's Lua snip video down in the description in case you want to continue your journey there. However, what I'd like to show you is what snippets are, and also how they work under the hood, because that's not something most people know about. How does the editor know where to place your cursor? I mean, surely it's not really that magical, right? Surely there's something going on here that we're just not aware of. Here's a nice thing I want to show you. We are now going to write our own basic snippet. So before we write our first snippet, where do these snippets come from? Well, they come both from the LSP server, which sends them over as a built-in part of its functionality, because apart from completions, LSP servers can also send over snippets. But of course, it also comes from this nice plugin over here. Friendly Snippets is a large collection of snippets for every programming language out there with a lot of quality of life features, and that's why I recommend that you have it installed. But what do these snippets really look like? So let's create our own snippet right now. I'm going to enter the command mode and I'm going to run a Lua script. And from this Lua script, I'm going to run vim.snippet.expand. And let's try and recreate that if statement that we had going on earlier. So inside of a string, I'm going to type if, and we're now going to build out the scaffolding for the snippet. I'm going to type if $1, then I'm going to set a new line, which basically means an enter key press inside of the editor. I'm going to add 2 spaces over here, which is going to indent the code afterwards. And then I'm going to press $2, then another new line, and I'm going to type end. If this looks confusing to you, we're basically creating scaffolding for a snippet. And we have these 2 magical things here, which are $1 and $2. Well, what this signifies is this tells the editor, I want you to first place the cursor here, and then I want you to place the cursor here. So first in the first dollar symbol and then in the second dollar symbol. So let's press enter and you'll see the snippet has expanded. We have an if statement. Our cursor is immediately placed in the $1 and I can type something like true, and then I can press tab again and that is now going to move me over into the middle of the if statement. How cool is that? We just created our own snippet. Just to show you the flexibility of the system, if I rerun the command that we had before, let's change the order. Let's make this $1 and then $2 and let's see what happens. So first you can see I'm moved into the content where I can type something like print hello world. And then when I press tab, it moves me upwards into the if statement where I can type out whatever I'm really looking for. So under the hood, when blink.cmp receives a snippet, it runs vim.snippet.expand, which actually does all of the magic for expanding the snippet and moving your cursor around. How cool is that? So that concludes all of the most important things that I'd like you to know about the blink.cmp completion engine and about how completion engines work in general, how they play with Neovim, how everything comes together really nicely. I really hope you enjoyed. If you do have any questions or if anything was unclear, if you'd like more clear examples or maybe more visualizations on the screen, then feel free to let me know in the comments. I feel like everything I've presented here is sensible. Maybe if you rewatch it twice, if you're particularly uninformed about various programming topics. I'd love to hear from you. Thank you so much for watching, and I'll see you in the next video. Ciao!